Okay, so this is kind of a tricky problem in terms of not the problem itself, but the formula is kind of tricky. So I've already written out the formula, and so not one that we would normally be able to predict. And now we have to do some balancing. And so oftentimes when you have these odd looking formulas, the balancing is also a bit hard. And so on this particular problem, what we're going to see is that we're going to need to use some threes, and those threes are going to kind of get us where we're going to need to be. And so we're going to end up with kind of a weird thing. And so this situation, so you have two nitrogens, and so you put a two here, and then you're going to end up putting a three here to balance out your hydrogens. See, six hydrogens there, and then two times three. And so that is sort of what gets us going onto those threes. And then the way to get it to work is then, okay, now we need the three oxygens, which kind of leads you over to those three coppers. So not super difficult to balance once you kind of get going. It's just that the formula is kind of weird. So we're going to write out our values kind of where we want them. So we've got the 18.1 grams of the ammonia. And so I'm going to go ahead and put that right on top of the ammonia. And then the 90.40 grams can go right here on top of our copper 1 oxide. And then we're going to put a question mark here, and it says mass. So we're going to be looking for grams. Okay, so anytime you see the word mass, then they're going to be looking for grams. All right. Now, one chemical not used here, water. So we're going to put the X over it. I really like that. Oh, sorry, two chemicals. That copper also not used. I like to do that to say, hey, I'm not going to confuse myself. All right. So now here we go. We have to solve twice. So we're going to solve twice. And both times we're solving for nitrogen. So we're going to solve twice for nitrogen. So you're going to get two numbers. You're going to circle the smallest one because just like the chocolate chip cookie example, you can't make more than the chemical that runs out is going to allow. So let's start. Let's go ahead and start with the ammonia. So we're going to go 18.1 grams. And there's our ammonia. And just like always, we just convert it over into moles. So we're going to have to add that up. So we're going to get our calculator, and we're like, okay, 14.01 plus, and that's going to be 1.01 times 3, and that's going to be 17.04. All right, so over here, mole ratio. All right, so let's refresh our memory on how that works. The item that I want is on top, and the item that I have is going to be on the bottom. So what do I want in this situation? Well, I want the question mark, right? So I want the nitrogen, which there's nothing in front of it, so that's 1 mole of nitrogen. So I want that. That's on top. And I have this ammonia, so I've got 2 moles of that. And let's plug that guy in on the bottom. Okay. And then it says mass. So if it said moles, we could stop, but it doesn't. It says mass. So we're going to go one more step, and we're going to go 14.01 times 2, and that's going to be 28.02 grams over 1 mole. And that'll put an equal sign there. All right, so we're going to run this through. Let's check our stoichiometry, make sure everything is canceling out. So grams are gone. That's awesome. Then the moles again, and there's the ammonia. So we're left with 3 things. Are they things we want? Nitrogen and grams. Well, yes, we want nitrogen and grams. So we're going to run that through. So 18.1. Make sure you're doing this in our calculator. So 18.1, make sure you're doing it with me. Divided by 17.04. Hit enter. Times 1 doesn't do anything, so I'll just divide by 2. So remember, I multiply here, divide here. And then last, I'm going to multiply by 28.02. And I got a pretty big number here, 14.88151408. And we're going to need to round that to significant figures. And so it looks like we've got 3. And so we're going to go 14.9 grams. Okay, so there's the first one, option 1. Now let's go to option 2. 90.40 grams of copper oxide. So you see I'm starting with a new chemical, so it's going to have some slightly different values. Still go into moles. We got to figure out how much that weighs. So we get our periodic table out and we take 63.55 for the copper, 63.55, and we're going to add it to the oxygen, which is 16. Now I'm no longer going back to your periodic table. Remember, I'm getting these values from your periodic table, but I'm assuming that you're able to do that, right? You don't need me to look at that every time. I just don't want you to be confused. So, and there we go. What are we going to be going to? Well, this is the cool thing about these problems. This back part here, that's all going to be the same because we're looking for the same thing. So because we're looking for the same thing, like I can just sort of replicate all of the back part. The only thing that's different is this bottom part. So I'm still looking for moles of nitrogen. This part down here is a little bit different because I've got this is what I'm looking at. It's what I already have. So 3 moles copper oxide. And this is identical. 28.02. Should be a point there. 28.02 over 1 mole. Let me clean that 28 up a bit. Okay. So now we're going to run through for the second option. So there's 2 options. So there's 14.9. So it's 14.9 chocolate chip cookies or whatever. And now here's the second one. So 90.40 divided by 79.55, enter. Times 1 doesn't do much. The divide by 3 does. So divide by 3. And we're going to multiply by 28.02. And I got 10.61390321. So let's go 4 sig figs. So 10.61. And so then this is grams of nitrogen. And this is grams of nitrogen. So here we go. We've reached sort of the end of the problem. And now you have a decision to make. So a lot of students don't do well here because they don't finish the problem, right? So we've gotten to the end of the line. So you need to circle the one that you think is the answer. And so the smallest one, so that's my answer right there. All right, so that is my product right there. So I go with the small value. And the other value does not occur. It never happens. It's like saying, well, I can make 50 chocolate chip cookies from 1 chocolate chip. That's not possible. It's never going to happen. So the other number is a fantasy number. It doesn't ever happen. So I want you to cross it out. Put an X on top of it. You never, ever, ever want to use that number. All right? So this kind of gets us that balancing piece. Then we went through the balancing, we went through the equation, we went through the 2 limiting pieces. We went through the whole thing, and what we come up with is that this right here, this is how much product is made because one of our chemicals runs out. So the chemical that runs out, this one, we call that the limiting chemical, and it can be called a limiting factor or a limiting reactant or a limiting reagent, but it's a limiting item. Okay. All right. So if we jump over here, you're going to see there's another one here and it has an extra piece. But what you guys should try right now is you should try to do everything but the extra piece. So maybe wait, if you're not comfortable, wait on this part. But go ahead and try the rest of the problem there. So go ahead and try the rest of the problem. So you can pause it, go through, try it, and then we'll pick up